I'm saying there isn't also an extra thing called time. If you use the word time, that's fine, but it's purely a kind of conversion factor, it's a notion, it's not... fundamentally what I'm saying, there was a video earlier where Stephen Hawking was talking about the possibility of firing a bullet into the past to kill himself, a version of the grandfather paradox. And this is what I'm saying that thing doesn't exist. If we take this tricky step where we go, oh yes, we're quantifying time, then we start thinking there's a future and a past. I'm saying there's absolutely no future and no past. We never see any reason to...
There's a lot of people who believe that, if you look at the computer language analogy where you go towards object-oriented programming, which is what which is sort of commanding what's happening on the internet at the moment, you then look at a package which is an object of distance and time, and what you're saying is rather than looking at it as a separate entity, as part of that package.
You lost me slightly. I will bring it back to this conversation. You might find that the next slides explain what I'm thinking more clearly.
Okay.
I'm really just saying that you start from first principles. You say, what do we see? We see things existing and moving. We never see a future. We never see a past. We see the contents of our mind. We see things changing, but we never see a future and a past. What I'm saying is I'm being ruthless about analysing this.
What you're saying is you can see that's a distance, that's clear.
Yeah.
What you're saying is that time is more abstract than that, much more abstract.
I'm saying it's utterly abstract. I'm saying the world is still incredible and amazing, but I'm saying you'll never...
The theory of relativity, just all that does is actually reinforce your argument.
No, I'm saying there's a misunderstanding of relativity. If you read it, I'm sure you have, if you read it carefully, Einstein at no point proves that there's a future or a past or a time that's needed. No, he doesn't. He starts off by assuming it. He says, I assume there's a temporal order to events that can't be analysed further, and previous talks do analyse that further. But let's move on. The other talks are on the International Net of Computers, you can look them up. So, did we cover that? Yeah, I'm saying that this twin on the spaceship just changes more slowly. I shouldn't have changed it in Einstein, that's just confused everyone, but whatever. Let's look at general relativity, and we'll just take a breath, right? We're going to do this whole thing in one go, okay? So that's good, there's no break to worry about. Do you need a break?
And how long would it be? 2 hours?
No, it's almost another kind of quarter of an hour.
Okay, that's not
Okay. General relativity is different from special relativity. What general relativity says is that, as you were saying earlier, if you have a clock near a massive object, this is meant to be a black hole, a super dense object. If you have a clock near a massive object, it will run more slowly than a clock that is away from a massive object. Literally, if you have a clock at base camp on Mount Everest, it will run more slowly than a clock on the top of Mount Everest. In a sense, getting rid of gravity frees up time. Gravity is almost like a tree or something, or things are more compressed and under gravity or warped or condensed. But literally that will be the case. The longer you leave them there, the more they'll show a discrepancy. But I'm saying even that doesn't prove that there's a past in the future. Black hole is really just a super dense object, for our particular example. They have wonderful properties, but we don't need to worry about them too much. There's a famous kind of paradox that says that if you have some astronauts orbiting a black hole very near its gravity, at a base station up here that's further away, a lot of very confusing things will happen. If it's agreed that these people here send a message once a day, checking on how these people here are, what will happen is these will end up getting a message like once an hour. And that will be very confusing for them. So we're on this base camp up here and we go, yeah, Starship 1, how are you doing? When they receive the message, it will actually be like, Starship 1, how are you doing? It'll be compressed and they'll be getting 1 an hour instead of 1 a day. Now they get confused and they'll send a message back to us saying, yeah, what's going on? You're sending us too many messages. And they might send that message out once a day or whatever. But as we get it, we'll hear what's going on. It'll be stretched out and we'll get it a lot less often. So this seems to be a very tangible example of a problem with time and time discrepancy, rates of times happening with the wrong rate, whatever. Someone's got to be sinking into the past, someone's got to be coming out of the future. But I think it can be looked at another way. Similar in a way to the twins paradox. The guy around here, everything's happening slower for him. The guy out here, he's going to be aging. And literally, if you had two twins in a situation and you left them long enough, one would come back. and they would be younger than the other. They would have achieved less. They would be more vital, whatever. So how can this be explained without time? General relativity, time dilation. Up here, if they send a message testing 1, 2, 3, here it will be compressed faster, appearing more regular. But you could simulate this. You could simulate this down on Earth if you had a couple of tape machines and some cassette tape that was actually rubberized and stretchy in one way or another. And if you literally set this up along a corridor and someone spoke into this microphone, their message here would get more and more compressed as it went down this little tape. I haven't shown a mechanism of compressing tape. And when they heard it here, it would be squeaky. And if they kept talking down here, you'd get more and more messages. And the point is, this is not exactly what happens there, but the point is to show that even this bizarre kind of effect, you could simulate very easily. And one of the main things that it shows is if I shout out the word hello and I send it out as a radio wave, and that radio wave lasts about a second, then it's going to be a pulse of radio signals that will be about 186,000 miles long. And that pulse of radio signals will go down and will get compressed. And when it's received here, it will be received slightly differently and it sounds slightly differently. So what I'm saying is that my message won't be sent over time. When I transmit my radio message, it becomes a pulse of radio waves. And that pulse of radio waves is a real thing that doesn't exist over time, it exists. It's got a length, it's got a whatever, and it's travelling at speed. And it gets squished as it gets near the black hole. And when they send a message back, it would be similar like a message being stuck on this tape on the other side and coming out. It's a vast oversimplification. What I'm saying is that you can explain things if they're just all here now, getting squished up or stretched out and moving at a speed and a distance. But we don't need to say that there's a mysterious extra dimension called time for that to work, in my opinion. So that's a simplification of that, enlargement of that. So what about Hawking's mad scientist paradox? How can we put this all together and explain? Are you familiar with that video or that thing? Okay, so obviously he starts off assembling the gun, he walks around the time porthole and he shoots himself back through the porthole. Here he could have, in theory, kind of look around and see himself, maybe dodge out of the way. Here he's looking himself back in the past, and so on and so on. It seems mysterious. Here he even has memories of himself doing that, and here he doesn't have those memories. What I would say is that the memories just formed in his head and he just walked around with them. But so how can we re-explain? This is my grand finale. Re-explaining Stephen Hawking's mad scientist paradox, but without time. Here Hawking is talking about very tame wormholes. This is a wormhole, two bits of distant space that are kind of merged or warped together because of the way that supermassive objects warp space and time. That's a nice opinion. Being clear, first of all, about how we come up with the idea of a wormhole. First, we see that mass warps space, or space-time, if we assume time exists. What I'm saying is that mass does warp space, and that mass also slows things down. If something's near that mass, it will be slowed down, but I'm not saying there's a thing called time that is also slowed down. I'm not saying there's a journey from the past into the future that's slowed down. I'm saying just the thing that's slowed down. So we get a mass and it warps space. This is the diagram that we use to show that. It's a very useful and intuitive diagram. Then the concept is expanded with the idea that the dip, as it is shown in the picture, becomes more and more extreme the greater and more tightly packed the mass is. So this is a much heavier, smaller, denser object that's warping space a lot more than that object. And in reality, black holes exist and they are awesome things. You know, the entire mass of the Earth could be fitted into the size of a pea, and that has awesome properties, and it really can happen. When gravity gets so strong, it overcomes all the molecular atomic forces and things collapse in on themselves and everything gets very, very weird. But this is what happens. We exaggerate this diagram. The diagram is exaggerated even more, and sometimes the detail of the mass causing the distortion is omitted, which I think is an important error. Okay, let me wrap this last bit up. I'd love to in places like that.
Yeah.
Very interesting. So what I'm saying is this. We get this idea of a wormhole. What Stephen Hawking is suggesting is that a wormhole kind of exists and that the mad scientist is shooting through that wormhole. So I'm just going to take you through what we think a wormhole is and what he thinks he shoot through and how I think I can really explain it. So we start off with this idea, walking of space, dense object walks space more and more. Then we sometimes lose this detail of the object that causes it, which I think is a critical error, but whatever. Then we consider the idea of mixing two of these things together. So thirdly, some might think two such areas walk space, or extended example, meet and form some kind of a wormhole through space-time. So we've already been sold this idea of space and time. I'm saying there's just space. Space is walked by massive objects slow down the rate at which things change, and so on and so on. But this is where we get the idea of our wormhole. But what I'm really saying is you should be careful as well to consider that a black hole is really just an object with a lot of gravity around it, and that gravity tails off with distance. And no matter how mysterious a black hole is at its centre, I don't think we should imagine that it's not just an object you could fly around, or an object you could put in a box if you had one, a few trillion light years square or whatever. But people think that because it's called a hole, you might be able to go through it, or there's something particularly mysterious in the middle. Note also the black holes are not holes despite their name. It was said when they were named that if one was in the sky, it would appear as if there were a black hole in the stars, because there are stars behind this thing. It's just that any bit of light that gets near it gets sucked in. No light can escape from it. While this picture seems to show a hole in space, it's really trying to show that there's a very dense object blocking our view of the stars behind it. This is a misunderstanding. If you want to know the difference between what is a hole and what appears to be a hole, you have to ask Wile E. Coyote. I'll tell you there's a very significant difference between something appearing to be a hole and actually being a hole. Nonetheless, we have this idea of a wormhole, different parts of space and time, and this is what we're suggesting, Einstein's suggesting, Hawking's suggesting. This is what this thing is kind of a condensed, stylized version of, in my opinion. I think this is what he's aiming at. Different parts of space and, Hawking saying, time, walked, meshed around. You could fire a bullet through there, you could look through there, whatever. This is where I think the origin of what he's trying to say is. My interpretation is slightly different. There are other slides that explain this more clearly. This is what I'm suggesting is that the glowing hole that the scientist is looking through and firing a bullet through. If you imagine you had a very massive object here, and you've got this scientist here, and at first he's assembling a gun. I don't think I've got this right. So the gun's on the ground, he picks it up, he puts the gun together, and he starts kind of aiming it. I'm trying to think if I got this the right way around. Yes, I have. I might be lost here, hold on a second. So what we have, we're considering two or three things at once here, but the images of the scientist can go whipping around this dense object and come flying back here. What he's looking at here are images of things that he's previously done. He can fire a bullet, that bullet will go flying out and it will orbit this massive object, and it will come back round and it will head that way. I'll break this down a little bit, hopefully. Same kind of thing again, I've broken it down differently. First thing we have to consider is that as things happen, as this bottle rocket flies out of its glass, images of the event fly away. If you could manage to be 500,000 or 1 billion miles away, you'd still see an image of the rocket in the glass. It's not the rocket in the glass, it's an image of the rocket in the glass. You shouldn't confuse the image with the object. The object is there, it's the real thing. But there's always a sequence of images flying away from any event. Anyone looking at distant stars will tell you that. We're seeing some image of a star, but the star itself will be very different now. We know that masses can bend light. This is, I won't go through all the text here, but basically it was an experiment done years ago to back up Einstein's theory of relativity. You had the Earth, you've got the Sun, they wait for there to be an eclipse, and they could see that the position of distant stars seemed to change. The light from this star came along, but then it was warped by the Sun, and it looked from Earth as if that star had changed position. So massive objects can warp light, they can bend light, they can bend the path of light. So this is what I'm suggesting. You've got a massive object, and you've got images of this scientist, and these images are being sent around that object in a certain direction. A strong enough mass could warp images around and back to where they came from, just images. Such a mass could also stretch space and send actual objects around itself back where they came from. So scientists shoot a bullet, and this bullet will orbit that object, hard words to say, and come back. If we put these two things together, you can imagine a situation where the scientist is doing whatever he's doing. Images of him are flying around here. These images would all be slightly different. This would be the first thing he did, that would be the second thing he did, the third thing he did, the fourth thing he did, and the current thing that he's doing. But these are just images. This is the only bloke who's ever real in the whole scenario. Now what he can do is he can look through his porthole. If you remember the original picture, he's got the gun, but he's looking at himself assembling the gun, and he fires a bullet. And this bullet goes through the images of his previous actions. There's never any past, never any future, it's just images, it's just one him. Direction, bullet, direction, the images. So he's firing that bullet, and the bullet goes all the way around, and ultimately, if he's good aim, he might manage to shoot himself in the arse, but not the past. He's got no reason to think that it even exists. So what I'm saying here is that he can be looking through his porthole, he can see images of the past, he can shoot at those images, and while he's expecting this character to drop when the bullet hits him, he'll actually get shot by his own bullet here completely unexpectedly. That's what I think would actually happen, that's what I think Hawkins is pointing at. I think the misunderstanding that there is a past comes from the fact that we look at our memories and we think that they prove something more than they do. To me, my memory just proves that things can exist and they can move and change now. The assumption that they also prove that there's also a past seems to me to be unfounded. So that's what I was saying at the beginning. You've got the guy here, images fly around that way, the bullet flies around that way, the bullet would eventually come and hit him in the shoulder. If you ever watch Mythbusters TV show, they did something where they just got a piece of bent tube, this is a cutout of the guy, not the real guy, and they fired a gun into this tube and the bullet went all the way around the tube and came out and shot him. And what I'm saying is that basically that Hawkins paradox is not a paradox, it's just a kind of thought experiment version of something that's really quite simple in theory and practice. So you could save yourself a few trillion euros and just copy Mythbusters TV show. That is the end of this particular version of timelessness and relativity. That's a round of applause. Any questions? There are more slides in case you're wondering, Tony.
Oh yes, there are. Are you going to buy me my first pint then?
Yes, I'll buy.
I think us two should go upstairs and you should watch the first 10 minutes.
But turning up late, I don't know, should I? Should you buy
no,
it to me for this free talk?
Time doesn't exist, you've already said that. But
Things
existence.
change.
Tragically, what exists are mortise bolts and people who look at motors on faces and making decisions.
Can you imagine how many time jokes he's got to listen to?
Yeah, I know, I made a rod for my own back, but yeah, whatever. Guys, thank you so much for coming.
No, thanks for doing the show.
I do appreciate that. I'll,
Yes, I'd like to hear the first 10 minutes if that would be interesting. But
these guys already heard it. But it'll be on YouTube, I'll put it on YouTube.
okay, it's
The,
on YouTube, fine.
The other things I was looking
Well,
at.
give a talk at Plonlav because you'll be.
Yeah, where is that? Is that...
Camden Square.
Okay, and where, you were saying every 2 weeks or something?
No, every month.
Okay.
And last, have a word with Matthew and see if you can come along.
That'd be great. I mean, I can do it at different lengths. I can do half an hour, or 2 hours, or whatever.
Well, Matthew manages about 5 hours. The people at Camden, the Irish Centre normally want us all to go because Matthew will do it on for hours. So you can keep on going as long as you want, actually.
Okay. Well, yeah. Well, I can.
In my only reservation,
Go on.
well, you disproved something that was absolutely ludicrous to me in the first place because I'm a layman who's never thought about that.
What was that?
The paradox, the scientist, the mad scientist.
Yes.
Whereas if you prove to me that smashing a glass on the table doesn't mean that glass once existed.
Oh, I see. Yeah, yeah.
I walk away going, oh right, things I thought weren't true. But you disproved something that I've never had proof of.
Yeah, it's because I've read
It's
the
a theory.
subject.
You disproved the theory.
That you
is
didn't
something
know
other,
about.
or that they've never proven to me. I've never seen a man shoot himself through the hole.
Yeah.
And if I did, and you put a different spin on it, I'd go, wow, I never thought of it like that. But you,
I see.
you put it in my head and then take it out of my head.
Well, what
You've argued with yourself. Almost.
Well, no. I've argued with Stephen Hawking.
No, I know, but to a layman,
Yeah.
because.
But no, I'm saying all the way through. I'm going. That's what Stephen Hawking said.
Yeah,
I'm
no,
saying
no,
this
sure.
isn't possible.
I
This
know,
isn't right.
but it's
so,
like it's
yeah.
almost like, you know what I mean?
Yeah.
you're proving
I've
something
started
else.
something up that you didn't think about.
Yeah.
but
It's you're winning an argument for someone who you had the argument in the first place.
This is something that always bugs me, right? You know, when people look at the stars and they go, we're looking back in time at the universe as it was a million years ago. But when you get hit by a tennis ball, you're like, fuck, I'm feeling something that happened 3 seconds ago.
Okay.
I'm saying that photons hitting your eyes, the same as a tennis ball hitting your head. It's all just happening now.
Is this the DVD extras?
Yeah, there's DVD extras with the commentary. Hubble Deep Field Image, you ever heard of that? So, you know the Hubble telescope?
I've heard of it.
It's up in space, they set it to take a picture, which is basically about a bit of space about the size of 5p at 100 metres away, a tiny, tiny speck of space. But they left the camera basically open for about 1 million seconds. They just left it on to take a really long exposure image. And they got this image, and this doesn't do it any justice at all, but it's a phenomenally detailed image that in a sense goes back 10 billion years into the past. They've got pictures of galaxies just forming. But what I'm saying about picture is that you've got this Hubble Space Telescope and you're running it. And what that picture really is of about 1,000 million kilometres of light in space. And those particles of light, those photons, hit the sensor and get recorded and then create this image. But that's a bit like running down a field with a butterfly net, 1,000 metres.
Okay.
You're just getting what's in that space. So this picture is phenomenal, but what it shows you is what's in apparently empty space. And we can reinterpret that as we're looking back in time, but you're not looking back in time. When you open a shutter, this photon here, it was headed in that direction. Just a load of stuff, almost like catching a load of dust.
Okay.
And we can interpret it, and obviously the initial cause was these galaxies, whatever, and they're in a different condition now because everything's constantly changing, but we're not looking back in the past if you want to be...
But it's not 1,000 million kilometres, it's 1,000 million light years, and the whole point is that some of these objects are several million light years away. They did take that million years to arrive. I think that's a fair assumption.
Yeah, what I'm saying is, what is this picture actually of? And I would declare that picture is actually of the photons that stretch from here out, 1 trillion kilometres
well,
away.
Clearly that's true, but it doesn't alter the fact that those that are nearer, because the photons are travelling at sea, you'll see a fresher version. Will be more
Absolutely.
recent than those that are several million light years.
And I'm saying don't get it
light
confused,
years
because if you're looking here, right, and this star's glaring away and it goes through a telescope, what you're really seeing is an image in the back of your eye. And we go, yeah, we're seeing this star as it was, blah, 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 and go, fair enough, in a sense that's kind of true, but when a tennis ball hits you on the head, you don't go, I'm feeling 2 seconds in the past. What hits your eye is what hits your eye, and that's what is here now, and it doesn't prove that there's also a thing called the past. That's my only point for discussing that image. Stars like raindrops, it's probably a bit too late for that. I'm kind of saying that star forms, it sends out loads of light. When you look at a picture like this, would you assume that a raindrop had probably fallen around about there sometime in the past? And what I'm saying is that's just here now. And yet by looking at something that's here now, we can make assumptions about what we think was in the past. But we're not seeing any example of the past at all. So looking around the world as it is now, you can tell about what may have been in the past. But it doesn't prove that there's also a past, a real past, that you could fire bullets into or visit. But I think many people make the assumption that there kind of is a past. And the fascinating thing is that if there isn't a past and there isn't a future, then there's just now. And that's where we're left. It's like stepping off a moving walkway. You go, whoa, do you know what? There just isn't a past.
I think you missed my point
Okay.
when I said if you integrated a period of time, this will always be in discrete units, however small they are. The size of those units will tend to infinitely small, but still be quantifiable. In that sense, you could argue that those units all exist discretely, and that might be a reinforcement for your argument.
Okay. But I'm saying that say we get some.
But the events happen nonetheless. If we take your if we take your 100-mile-an-hour car, which is going down Haverstock Hill, at some stage it will go past a photographic shot. But being a skillful driver, unlike a certain Greek singer or singer Greek extraction, you won't crash into it.
Wham!
Wham! Somebody wrote that on the wall, didn't they? So you go past that, and at one stage, call it time if you like, you will have been discreetly there. Another stage, you will be going past here. Another stage, you will. Where we are. Another stage you'll be going past Chalk Farm Station, and another stage you'll be going past Cheltenham Town Station.
Yeah.
Yes, you can. I mean, but you know, there's nothing in the assumptions about time that denies the fact that these are discrete events at a discrete stage in time. This is the whole point. And what you're saying is they're just discrete. What you're saying is that discrete entities. It's quite interesting.
What I'm saying we take a step back and we say, what do we observe? I observe things moving and changing, and that I can compare them. Now from that position, if I add anything to that I don't really observe, then it really has kind of no place there. So if I start talking about things moving and changing in terms of time and whether it has discrete events and so on and so on, I'm kind of making this thing up as I go along that I've never seen. I just see things moving and I can compare them. I know it sounds really odd and it sounds almost like a disappointment or a letdown. It sounds like something's missing.
If you go beyond Einstein's theory of relativity, which is only a stage, and go into quantum theory, then this is the whole point that I'm saying is every one of these, and this is how we can advance into maybe up to 12 or whatever dimensions. These are all discrete items, they're quantifiable, and that's the whole point. And this is where it gets interesting. And in a sense, time is just a quantifiable entity. In fact, it clearly is. And in that sense, talking about the past and in the future, the way we understand, you're absolutely right, is correct. But this is not new.
But surely it's new to Stephen Hawking, or he wouldn't have made that video.
Well, I mean, Einstein and Niels Bohr were sort of loggerheads for a long time because Einstein just didn't. I don't think he ever accepted quantum physics.
But in quantum physics, there's a thing where they say for a particle to make a quantum leap, it can borrow energy from the future as long as it pays it back very quickly. And I'm saying absolutely not, because you've got no reason at all to believe there's a future. Particularly if your belief that there's a past